Hello. Yeah, audio, video, everything fine. Hello. Yeah. Okay. So let's get started. This is the topic of number system. Okay. Now, yes, Shweta. Good afternoon. Audio. mm, yeah. Is it fine now? Okay. Now let's get started. So the topic is number system, and this is the most important topic of CSAT. Okay. You may like it or not, but this is the most important topic. This is the topic they have been asking most questions from. If you see, especially in the last few years, so earlier it was still a normal topic, but now if you see from last 3 years at least, it is like 23 in 2023, 24 in 2024, 25 in 2025. So if you go by this pattern, then it will be 26 in 2026. Okay, now the thing is that in number system topic, I am taking it a much wider topic. Okay, that is, it includes many other small topics like HCF, LCM you might have heard. Okay, all those small topics are I'll also cover in number system only. Now here, if you see the number of questions, now in this our target will be to get to at least a good number of questions, like 12 to 14 questions. If we can prepare well, that is our aim. So if let's say there are 20 to 25 questions, 12 to 14 is our aim. Okay, if we try to do every question, then most people will get just scared and stop doing anything in number system. Don't do that. There are plenty of very easy questions also that you get in number system. Okay, now let's get started. First thing is this you might have seen. Okay, this is what, this is natural numbers. Natural numbers are what? The counting numbers, 1 2 3 4 5 6, like that. So counting numbers are natural numbers. Then in whole numbers you include 0 as well, correct? Then you have integers. Integers is when you include negative numbers as well. Then after that you have something known as rational numbers. That comes when you in integers you include decimals and fractions as well. For example, 1 by 2, 0.01, all that. If you include that, becomes rational number. One more thing about rational number is they can always be written in P by Q form. Okay, then there is something known as irrational numbers. Now this is non-terminating, non-repeating decimals. We'll see how it works. Okay, so this is irrational number. The correct definition of irrational number is actually numbers which are not rational. The real numbers which are not rational are irrational. That's why it is named also irrational. Example of this is root 2, okay, pi, all this, they just never end. Okay, so that after decimal, what numbers you have, they just never end, and they don't have a pattern also. So that is irrational numbers. Now if you see the diagram, so natural, whole, integers, rational. Now rational and irrational I have drawn separately. Why? Because they cannot have anything in common. Then an all encompassing set is the real numbers, which has the rational as well as irrational numbers. So real numbers is simply rational plus irrational numbers. Okay, now let's do this question. Very simple, simply from the diagram only you can do. Every natural number is a real number. Yes, of course, everything was inside real numbers. Every real number is a rational number. Is this true? No. In real numbers, you also have irrational numbers. Correct. So every real number is a rational number? No. Then every integer is a real number? Yes, real number is a much larger set. Every rational number is a real number. This is also correct. Real number is the largest set. So 1, 3 and 4 are correct. Answer becomes B. This is just for your practice. Then now let's get to the, see, there are questions that are based on this only, that is which of these will be even, odd, all that. But actually if you look at them carefully, those are miscellaneous question that involves the concept of factors also, sometimes LCF, HCF also. So that we'll deal later. Now let's get started with these two terms. So our topic is divisibility, but before that we need to understand something known as factor and multiple. So what is a factor? Okay, A is a factor of B if A divides B completely and leaves remainder 0. Correct? For example, I write here that 3 is a factor of 12. Why factor of 12? Because when 3 divides 12, when 3 divides 12, it goes 4 times minus 12, it leaves remainder 0. This is why it is a factor of 12. This you understand? Can you fill this blank? Dash is a factor of every number. Fill this blank. Dash is a factor of every number. Can you think of any number which is a factor of every number? Now see, which is a factor of every number. Now any number you divide by 1, it divides it completely. Correct? 13 divided by 1 goes 13 times. What is the remainder? Remainder is always 0. So actually 1 is a factor of every number. Understood? Then you come to multiples. Now what are multiples? So A is a multiple of B if for any random number W, any whole number W, B into W is equals to A. Or we must have seen this in table, that is 2 ones are 2. Okay, then 2 twos are 4, then 2 threes are 6. So what is this? This is any number B being multiplied by any whole number W. And what are these? These are the different values of A you are getting. So all these A are what? All these A are multiples of B. This is the whole point. So basically you take any number, you start multiplying it with whole numbers. The numbers that you get are called its multiples. Okay. Now by this logic, if you go by this logic, which dash is a multiple of every number? Which number is a multiple of every number? Yes, Dheeraj, correct. Which number is a multiple of every number? Now here I have written any whole number W. Correct? Whole numbers, if you see here, whole numbers also includes 0. Now if you look here, so now any number, for example, let's say I take 143. Now 143 multiplied by any whole number, let's say that whole number is 0, what you get? 0. Correct? So this 0 actually becomes a multiple. Now I have taken 143, you can take here 3 into 0 will also be 0, 2 into 0 will also be 0. For any number when multiplied by 0, that is a whole number, you get 0. That is, it is a multiple of, that is 0 is a multiple of every number. Okay, understood? So this is factor and this is multiple. Now if you understand this concept, then we can start learning about divisibility rules. Now this is divisibility rule. I have divided this into 5 sets. Okay, this is the set 1, which is divisibility rule of 2, 4 and 8. Of 2 is last digit is a multiple of 2. Last digit is a multiple of 2. What are the possibilities? If last digit is a multiple of 2, the possibilities are it can be 2, correct? Last digit can be 2, or it can be 4, or it can be 6, or it can be 8. Any more possibilities? It can be 0 also. because 0 is a multiple of every number. So here I can put 0 also. This is the complete set of last digits that are possible. That is 2, 0, 2, 4, 6, 8. If you find this in the last digit, it is divisible by 2. Simple. Then for 4, last two digits are a multiple of 4. Last two digits will look something like, now you know 0 is a multiple of every number. So it may be 00, last two digits, or 04, correct, or 08, and it goes on till like 96. If you remember from calendar, this is the largest two digit number divisible by 4. Then for 8, now you understand, it will be like 000, 004, and it goes on like this. 008 goes on like this. Understood? So this is the whole concept of multiples of 2. This is 2 power 1, so only last digit is seen. This is 2 power 2, so last two digits are seen. This is 2 power 3, so last three digits are seen. Correct? Let's do this example. Tell me. Check it for 2, 4 and 8. Tell me if it is divisible by all of them or if not divisible by any. Yes, Neelam, hello. Okay, so 2, 4, 8. Only 2. Okay. Now, how do we see this? So, if we want to see divisibility with respect to 2, what it will be? Divisibility with respect to 2, I have to look at only the last digit, that is 6. 6 is divisible by 2, so this is also divisible. Then for 4, what I have to look at? For 4, I must look at 76. Now, is 76 divisible by 4? Huh? If you remember the table, then fine. Otherwise, you just divide it. This goes 1 by 4. This goes one time. Minus 4. Correct. This becomes 36. 36 means how many times? 9 times. Minus 36 and 0. Correct. So there is, the remainder is 0. That means it is divisible by 4 as well. Then for 8, I have to check 676. Correct. So now 676, if I try to divide it by 8, this goes 8 times minus 64. Correct. 3 remains with 36. Now 36, how many times 8 will go? 4 times minus 32, that is cross 4. So 4 remainder came. Remainder should have been 0 if it was completely divisible. So because I am getting 4 remainder, not divisible by 8. Yes, Dheeraj, correct. So only 2 and 4 are dividing it. Very easy. See 1 digit, 2 digit or 3 digit if it is 2, 4 or 8. 16 also you can understand. Correct. 16 will be what? Last 4 digits are a multiple of 16. Like that you have to check. Other digits does not matter. Then let's see the set 2. Set 2 is 3 and 9. Now the rule is sum of digits are a multiple of 3, or for 9, sum of digits are a multiple of 9. This you know. Okay. Now, another way you can do this is by creating and cancelling multiples of 3 or 9. Okay. Whatever is the question. For example, this is an example. Now, for this, I need to check divisibility with respect to, let's say, 3. So, I'm checking for 3 here, and on the other side, I check for 9. Now, one way is of course by adding all the numbers, correct, and trying to get to the single digit number and see if it is divisible by 3 or 9, or other method. See the other method. So what you have to do, you just start cancelling out multiples of 3. So now 2 plus 1, first thing is 2 plus 1, it is 3, gone, multiple of 3. So you can take one number, two number, three numbers, whatever, the sum should be a multiple of 3. So 2 and 1 is gone. Then 9 is a multiple of 3, so 9 is also gone. 6 is a multiple of 3, yes, so gone. 5 plus 4 is again 9, correct, so this is also gone. 9 is also gone. Then 4 plus 1 is 5, this is not completely divisible, but 4 plus 1 plus 1, correct, 4 plus 2 is 6, all three together you can cancel, correct. Now if all are cancelled, this implies this is divisible by 3. Simple. Now let's check for 9. For 9, what I'll have to do? I'll have to find multiples of 9. So now first thing, I see 9 here. Can I cancel it? Yes. Directly I'm cancelling 9. Then 6 is not divisible, but 6 plus 2 plus 1, correct, this is 9. So 2 plus 1 is 3 and 6 is 9, so I cancel these two. Then 5 plus 4 is again 9, so cancel. Then 9 again I cancel. Then 4 plus 1 plus 1, now this is a problem. 4 plus 1 plus 1 is 6, correct. Is it divisible by 9? No, correct. 6 is not divisible by 9, so that means all are not cancelled. All are not cancelled, that means this implies not divisible by 9. Now the good thing is whatever remains, that you can use to find remainder also. So 4 plus 1 plus 1, 6 is remaining, so straight away from here you can write the remainder would come out to be 6. Simple. Understood? So this is divisibility by 3 and 9. You have to create and cancel multiples of 3 or 9, whatever is required. Okay, then do this question. Try this question. This is from CSAT 2019. How many values of B are possible? Now, what we have to do? How many values of B are possible? Okay, now first thing, if I have checking divisibility by 3, what I'll do? I will create and cancel multiples of 3. So now 4 plus 2, 6, cancel it. Then 5 is not a multiple, leave it. Then 7 plus 2 is 9. 9 is a multiple, correct? Cancel it. Then see this. 5 plus 4. 5 plus 4 is 9, is a multiple of 3, correct? So I cancel this and this also. Now 6. Is 6 a multiple of 3? Yes, 6 also cancel. What remains? Only B remains. Now what can be B? What can be B such that it is divisible by 3? What are the possible values of B such that it is divisible by 3? What are the possible values? Now of course it is a single digit number, so it can be 3, correct. 3 is completely divisible. 6, 9, correct. 12, can you have 12? No. Why not 12? Because this becomes a 2-digit number. So 12 is not possible, but there is one more possible that sometimes students tend to forget, that is 0. 0 is also a single digit number, that is a multiple of 3 or completely divisible by 3. 0 by 3 is what? 0. Complete whole number you get. So how many possible values? There are 4 possible values, 0, 3, 6, 9. Yes, Dheeraj. Then now see this. So now it says 5 and 10. This is set 3. Very easy. Last digit is 0 or 5. Then for 10, last digit is 0. Simple. If 0 or 5 it is there, last digit, for example, 1, 2, 2, 2, 5. Now this is very clearly divisible by 5. Or if it is 1, 2, 2, 0, then this is divisible by 5 also and 10 also. This you understand. Then, now let's see of 7, 11 and 13. This is set 4. This is important. Okay. Now, for 7, 11 and 13, these are special numbers and they are prime. Okay. Now, for them, the series that we have to follow is 1 minus 2 minus 3 minus 1 2 3. This is for 7. Now, how do I apply this? Simple. These are the 6 digits that I have to consider. For example, if I give you a question like 2842, this you very clearly know. 2842, if you see this, this is very clearly divisible by 7. 28 goes 4 times, then 0, and 42 gives 6. That is completely divisible. Now, how do I apply this series? So what I do, I start writing the terms one below other. So this 1, and then the next is minus 2, and then the next is minus 3, the next is minus 1. Now I do what? I just multiply them correspondingly and then see what is the number I am getting. So 2 into 1 is 2, then 8 into minus 2 is minus 16, 4 into minus 3 is minus 12, 2 into minus 1 is minus 2. Correct? Now if you see, so what I have done, I have written the number, just below it I start writing my series. 1 minus 2 minus 3 minus 1 2 3. This is for 7. So I start writing, then I am multiplying them, and whatever I get, plus minus whatever I get, I will add them all. Now see, 2 and 2 cancel out, then 16 and 12, so what you get? Minus 28. Now minus does not matter. What matters is this. Is this number divisible by 7? Yes, it is. 28 is divisible by 7. That means this implies that 2482 is also divisible by 7. This is the simple method. Even if you get a very long number, what you have to do, you have to just write the series and then find out the overall sum. If the overall sum is divisible, correct, then it is divisible, otherwise not. This method does not give you remainder. Like in that 3 and 9, you also get the remainder. This does not give you the remainder directly. Only tells you divisibility or non-divisibility. Now, for 11, the series is very famous. That is sum of odd terms minus sum of even terms, or 1 minus 1, 1 minus 1, 1 minus 1. Then for 13, it is 1, 4, 3, minus 1, minus 1, minus 3. These three series you have to remember. This you anyway remember. For 7 and 13 also you try to remember. Yeah. Yeah, I think it's fine now. Now, now try this question. Okay, so if R and S are different integers, both divisible by 5, then which of the following is necessarily true? R and S are different integers, both divisible by 5. Now, see, if you read this question, these two numbers are both divisible by 5, then you need to tell what is the relation here. For example, r minus s, is it divisible by 5? R plus s, r into s, and like this. Now, see how you should be assuming the numbers, that becomes important. Of course, you can do this using the more like traditional method, that is, you take the two numbers as 5a and 5b, let's say, and then start solving it. But a much better way is you just think of some examples. Now when you are taking examples, try to take very different examples so that most of the cases are covered. For example, I take here example of, let's say, 5 and 10. Okay, this can be one example. Other can be 5 and 15. Correct? Now, if you look here, these are the two examples. Why I have taken these two examples? Because one of them is divisible by just 5, and the other has, so this ends at 5, this ends at 0, this ends at 5, this also ends at 5. I can also take 10 and 20. This can be another example if I want to take. These are the three possibilities, correct? So this is how you take examples. That is 5 last digit 0, then 5 last digit, 5 last digit, 0 last digit, 0 last. These are the three possibilities. Now let's start looking for the answer. Okay, so this I have written SR. Okay, now want to take anything. Okay, R and S. Now R minus S is divisible by 5. Now I check for this 5 and 10. For 5 and 10, this holds, correct? 5, 10 minus 5 is 5, divisible. Then for this also it will hold. Now R plus S is divisible by 10. R plus S is divisible by 10. What is R? R is, let's say, 5 and S is 10. So what it becomes? 5 plus 10, this becomes equal to 15. Now is 15 divisible by 10? 15 is not divisible by 10. So it is asking you which is not necessarily true. Answer becomes B. If you look for other options also, so R and S, if you take any of them, for example 5 into 10, so this comes out to be 50 divisible by 25. Then R square into S square, again this will be like 5 square into 10 square. So ultimately both of them have 5. So whatever you get here, it will be divisible by 5. So all others are necessarily true, but this is not. Okay, then next, try this divisibility by 7. Value of digit P. See, this series you have to apply. This 1 minus 2 minus 3, then minus 1 2 3. Okay. Now again, if it is more than 6-digit number, what you do? You write this. You start writing this again. So now I start writing this again. So this becomes 1, then minus 2, then minus 3, minus 1, then 2. Now I just multiply them and see what I am getting. So I multiply them. 3 into 1, this becomes 3. Okay, then 7 into minus 2 is minus 14. 9 into minus 3 is minus 27. 8 into minus 1 is minus 8. 1 into 2 is plus 2. 2 into 3 is plus 6, then 5 into 1 is plus 5, 2 into minus 2 into p is minus 2p, then this is minus 9, this is minus 6, this is plus 80. Correct? Now what you do, you collect all the positive terms. So 4, 3 is here, 2, 6, 5, 80. What you get? 3 plus 2 is 5, 5 plus 5 is 10, 10 plus 6 is 16, 16 plus 18 is 16 plus 18 will be 34. So this becomes positive 34. Now you see all the negative terms. So negative terms is minus 14, minus 27. So this becomes minus 41, minus 41 and minus 8, minus 49, minus 49 and minus 9 becomes minus 58, minus 58 and minus 56 is minus 64. One thing is still remaining, that is the minus 2p. This becomes minus 2p. 34 minus 64 is what? 34 minus 64 is minus 30 minus 2p. Minus you can put together, so this becomes 30 plus 2p. Now you tell me, this 30 plus 2p has to be divisible by 7, correct? Then only it is written that this particular number is divisible by 7. So that means 30 plus 2p is very clearly divisible by 7. Then what might be the value of p? Can you think of value of p? P is a number, correct? P is a natural number. Now, so 30 plus 2p has to reach to some multiple of 7. Can you think of multiples of 7 greater than 30? So 35. But for 35, p will come out to be 2.5. So not 35. Then you look for 42. So 42, correct? For what value you will get 42? So you can just equate them. 30 plus 2p is equals to 42. 2p is equals to 42 minus 30, that is 12, or p is equals to 6. Correct? Now in this, if you look for the option becomes B, that is p is equals to 6. Okay, Shankar. Yes, Dheeraj. Yes, Shweta. Okay, now some people who are very good at calculation, that is they divide very fast, they can also do this question just by putting the values if they like it that way. That also is fine. What I want is you just reach the answer correctly. Okay, then now this is the last set that we have to do in divisibility. So what we have seen 2, 4, 8 like this, then we have seen 3 and 9, then we started seeing 5 and 10, that was easy. Then after that we saw 7, 11, 30, and this is the last set, which is the composite numbers. Now in composite numbers, how you find the divisibility rule? So composite number, just choose a pair of co-prime numbers, that is it, on multiplying which you will get that composite number. For example, if you take 12, now 12 can be written as 1 into 12 is not very useful, but it can be written as 2 into 6, can also be written as 3 into 4. Others will be just reverse of this, 4 into 3 or 6 into 2, same thing. Now among these two, which one should you be choosing? So you should always be choosing co-prime numbers. What are co-prime numbers? Numbers which do not have any common factor. For example, now see, 3 and 5 are co-prime number. This you intuitively also understand, correct? 3 and 5 are prime numbers. Of course, they don't have any common factor other than 1. Other than 1, they don't have any common factor. Do not have any common factor other than 1. Now, so you understand that 3 and 5 are co-prime number. This you do get because both are prime. Of course, they don't have a common factor. But numbers like 3 and 8, this is also a co-prime pair. Why? Because 3 and 8, even though 8 is not a prime number, 8 is 2 into 4 or a composite number, but still because 3 and 8 do not have any common factor, they are called co-prime numbers. Understood? So for co-prime, what you are looking for, that they should not have any common factor. Now if you look here, 2 and 6, do they have a common factor other than 1? Yes, 2 itself. And that is why 2 into 6 should not be chosen. What should be chosen? 3 and 4. Now once you have got this pair of numbers which are co-prime, now the divisibility rule of 12 is very easy. That is divisibility rule, whatever is of 3 plus divisibility rule of 4. You apply both of them separately. If both are satisfying, then it is divisible by 12 as well. Then similarly, can you see, can you tell me the divisibility rule of 6? Now if you remember, this you must have learned when you were small, that is divisibility rule of 6 is divisible by 2 plus divisible by 3 both. And this is how you are getting this, because both are co-prime numbers, 2 and 3, and 2 into 3 is 6. Then similarly, I try for divisibility rule of 18. It will be what? Now think of all the pairs, 3 and 6, 9 and 2, but 3 and 6 have a common factor, that is 3. So what it will be? It will be very simply divisibility rule of 2 plus divisibility rule of 9. Understood? Similarly, 24, what you will do? 24, tell me what will be the divisibility rule of 24? What should be the two numbers? 24 can be written in many different ways. Okay, so what it will be? It will be simply divisibility rule of 3 plus divisibility rule of 8. Why? Because 3 and 8 are co-prime numbers. Otherwise, if you try to take 6 and 4, they have a common factor. So those are not allowed. 12 and 2 also common factors. Then, yes, Dheeraj. Then, if you have understood all this, then just for this number, tell me, is it divisible by 12, 18 and 24? Check the divisibility. Check it. Tell me which is dividing it completely and which is not. So for 12, what I'll check? We have written above 2 and 3. For 18, I'll check 2 and 9. Then for 24, I'll check 3 and 8. Let's start checking. So 2, very clearly, last digit is 2. So 2 is divisible. 2 is divisible. Then for 3, what I'll have to do? I have to create and cancel multiples of 3, or I can just take the addition also, that is sum of digits. Let's do it using sum of digits. Okay, that we have already done. Now 2 plus 1 is 3, 3 plus 8 is 11, 11 plus 4 is 15, 15 plus 2 is 17, 17 plus 8 is 25, 25 plus 5, 25 plus 5 is equals to 30. This is the sum of digits. Now, once you have got sum of digits, is it divisible by 3? Yes, 30 divisible by 3. Now, from this only, you get one more thing. So, 3 is divisible, yes. One more thing you get, that is 9. Is 30 divisible by 9? Sum of digits is same, correct? But 30 is not divisible by 9. So, here it is not divisible. 2 was anyway divisible. Now, I only have to look for 8. For 8, what I'll do? 832. So, 832 divided by 8, this goes one time, minus 8, gone. 32, how many times? 4 times, minus 32, and this remainder comes out to be 0. That means divisible by 8 as well. Now if you look at this figure, it is very clearly 12 is 12 is a factor of this number. Then if you look for 18, divisible by 2 but not 9, so 18 is not a multiple. Then 24, 3 and 8 both are divisible, correct? 24 is also a factor of this number. Yes, Dheeraj. Yes, Neelam. Understood? So these are the 5 ways in which we had to see divisibility. Now we'll see more questions. Okay. Yeah. Let's do this. Very simple. Yes, Shankar. Oh, I have taken, oh, sorry, sorry. So I should have taken it 3 and 4. Okay, this is wrong. So 12 is 3 and 4. Sorry. So basically 12 is what? I have to take again co-prime numbers. So it has to be 4 into 3. 4 into 3, that gives you 12. Now if you check for 4 also, 32. 32 is very clearly divisible, correct? 32, 8, 4 8s are 32. So again 4 also is divisible. Answer remains the same, but the part that I took here, that is 2 into 3, but that was wrong. So 4 into 3, 12, same answer. Then now it says what? It says statement is all numbers are divisible by 2. Okay, so this is some set. Okay, this is some set that has many numbers filled within it. Many numbers are filled here randomly. Now it says all the numbers are divisible by 2. So that means whatever number I have here are even, correct? Divisible by 2, correct? So all of them are divisible by 2. Now it also says all numbers are divisible by 3 as well. Now if it is divisible by 3 also, then what you can say, that whatever number are in this set, they are divisible by 2 as well as divisible by 3. What does this imply? This very clearly implies that it is divisible by, this whole set is divisible by 6 also, because this is the divisibility rule of 6. Now conclusion 2, all the numbers are divisible, sorry, conclusion 1, all the numbers are divisible by 6. Yes, perfect. Then all numbers are divisible by 4. Is this correct? No, you cannot say this. Divisibility rule of 4 was completely different, last 2 digits. Can you tell me any number that is following this property? 6 itself, you will have 6 here, correct? You will have 6 here. Now 6 is divisible by 2. Yes. 6 is divisible by 3. Yes. Is it divisible by 6? Yes. But is it divisible by 4? No. That is why conclusion 2 becomes wrong. Answer becomes only conclusion 1 follows. Yes, Anurag. Yes, Neelam. Yes, Shweta. Okay. Then a digit n greater than 3 is divisible by 3 but not divisible by 6. Which of the following is divisible by 4? You don't need to do all these questions using the traditional method of just assuming the number to be n and all that. You read the first statement, a digit n greater than 3 is divisible by 3 but not divisible by 6. This is the given statement. Now just think of any number that you can that satisfies this property, then it must be followed in whatever is asked in the question as well, because this is the only given part in the question. Okay, so now can you think of any number n? Now there are two things. One is n is greater than 3, correct? The other is that it is not divisible by 6. N is greater than 3 and it is divisible by 3. Now can you think of such a number? greater than 3, okay, then divisible by 3. Now what are the multiples of 3? Correct. So multiples of 3 are 3, 6, 9, 12, like this. Now of course this cannot be 3 because it is greater than 3. Then not even 6. Why? Because it says not divisible by 6. But if you look at 9, 9 is that beautiful number. Correct. 9 is greater than 3, divisible by 3, yes. Not divisible by 6, yes. So 9 is that number. So that means because it is a general property, if I take n is equals to 9, it must be followed in all the options as well. Now if n is equals to 9, now I have to check which of these will be divisible by 4. Which of these will be divisible by 4? I put n is equals to 9 here. What I get? 2n is equals to 9 into 2 is 18. Is it divisible by 4? No. 9 into 3 is 27. Divisible by 4? No. Then 2n plus 4. So 9 into 2, 18. 18 plus 4, 22. Correct? Divisible by 4? No. Last. 9 into 4. Sorry. 9 into 3, that is 27. 27 plus 1, 28. Is 28 divisible by 4? 28 divisible by 4? Yes. Answer becomes D. Now, one thing I am writing as a note here. Whenever same operation is to be done in every option, you should always start from option D. That is, you always start from the bottom. Now here you see consecutively you're just applying the same principle, that is you're just putting the value of 9 and then finding out if it is divisible by 4. Now this is same operation being done multiple times in each of the option. If such is the question in any topic of CSAT, you always start doing it from the last option, because the examiner also knows that you start from the first one. Now of course if the same repetition has to be done, he will try to keep the answer in the lower part, so that you have to do at least it 2-3 times or 4 times. Correct. So always start from D. Usually you will find B or C as the answer. Okay. Then next is these special numbers. Now so this is not originally a topic in number system, but there are some special numbers that somehow UPSC likes a lot. Okay, so I have created a subtopic out of it. This is special numbers. We learn about them because they are repeating questions based on these. Now first beautiful number is 111. Now triple one is actually 3 into 37. Okay, so what are its factors? 3 and 37 are its most important factors. One is of course a factor. One we don't even usually consider. One is a factor of every number, so that does not give any special property. Correct. So now 3 into 37. Then there is another important number, that is 1001. 1001 is 7 into 11 into 30. If you remember, this was our set 4. Correct. 7, 11, 13, for which we had the series. Multiplication of all these three leads to 1001. Now first you see this also. So triple one, if triple one has 3 and 37 as factors, then triple A will have what? I can simply just take A out here, so it becomes A into triple one. Correct. So this becomes A into triple one. Or what are its factor? A is a factor, of course. 3 and 37 are also its factors. Fine. Then similarly I do it for this also. 1001 I multiply it with A, so this becomes A into 7, 11, 30. Fine. Now if I multiply these two, then I actually get triple one. Okay, if you want you can multiply and see. So triple one into 1001 is triple one. Okay, if you want to see. So 1001, then 1 cross, then 1000, then 1001, then 2 crosses, then 1001. Can you see all of them adding 1 1, then 1 1 1 1? correct? So 6 times 1 is what you will get. Now if you get this, so triple one triple one becomes what? Triple one is actually equivalent to, this is actually equal to triple one into 1001. If this is so, what are its factors? Of course 3 is a factor, because 3 into 37, then 7 11 13 from 1001, and then 37 as well. These are its factors. Understood? So you always have to remember these two, and then it becomes easy for triple one triple one. Now if you have similarly triple a triple a, that is repetition of any digit. A can be anything. That means it can be 333 333, correct? So that also will have factors a into 3 into 7 11 13 and then 37. Now one more, the last one, that is 1 2 3 1 2 3. Now 1 2 3 1 2 1 2 3, how do you get this? If you multiply 123 by 1001, you get this number. Okay, you can multiply and see this I have multiplied, so you can believe me. So 123 into 1001 is 123 123. This you remember? Okay, now this in general form is actually xyz xyz, that is, for example, any numbers 216 216. This also works, correct? This will be equal to what? This will be equal to 216 into 1001. Any number written like this, any three numbers and then repeated again, this is equals to the three numbers into 1001. Now if this is so, then xyz xyz is equals to xyz into 7 11 13. Why? Because one, it is into 1001. Okay, these you have to remember a little. Okay, now yes Neelam. Okay, now if you get this, now I can show you many questions that are from this only. See this 2015 question. If ABC into D is equals to D double ED is equals to ABC ABC, then what are the values of D and E? Tell me what this looks like to you. What do, what do you think? So very clearly, this feels like what? If you remember XYZ into, so this is like, now see, ABC into 1001 will be equal to what? Will be equal to ABC ABC. You can see it from here, correct? XYZ into 1001 is XYZ XYZ. You get ABC into 1001, it's ABC ABC. That means what is D? What is D? D is 1 and E is 0. So answer becomes C. D is 1, E is 0. Simple. Okay, once you know this, it becomes very simple. Now you see this, this is XYZ XYZ. This is 2023, very difficult paper it was, supposedly. So XYZ XYZ, now it is asking you, for any choice of XYZ, the 6-digit number is divisible by what? Now you know what is this? This is XYZ XYZ into 1001. From this 1001, what you get? 7 11 30. Now if you see the options directly, 7 11 13 is what it is divisible by. Simple. Yes Dheeraj, yes Shweta. Then let's do another. There are 4 prime numbers written in ascending order. The product of the first 3 is 385 and that of the last 3 is 1001. Now you don't even need to think anything. The last 3 are prime numbers, correct? Last 3 numbers, 4 prime numbers are there, is giving you 1001. What are those numbers? 7 11 and 13. So you know the 3 numbers already. Now what should be the first number? 3 numbers you already know. Now what should be the first number? You see here 385, it must have 5. Otherwise from 7 11 and 13 you can never get to something which ends with 5, correct? So the first number has to be 5. 5 7 11 13. These are 4 prime numbers written in ascending order. What is the first number? First number is A, that is 5. Simple. Okay, then see this is the last thing. Triple one into triple one is actually very special. It is actually equal to 1 2 3 2 1. Okay, you can multiply it and see it will come out to be 1 2 3 and 2 1. Then 4 times 1 into 4 times 1 comes out to be 1 2 3 4 3 2 1. So that means if you see it carefully, this is number of times you repeat 1. For example, let's take this 1 1 1 1 1, 5 times 1 and 1 2 3 4 5 times 1. Now till that number, because there are 5 ones, so you have to go till 5. So you start here 1 2 3 4 5, you stop at 5. Now you start writing in reverse order as 5. So from 5 you start 4 3 2 1. Correct? You don't have to multiply, you understand the pattern. Correct? So 1 2 3 4 3 2 1, 1 2 3 4 5, then 4 3 2 1. Understood? Now if you take any number, so for example, if it is 1 1 1 repeated n times into 1 1 1 1 repeated n times, what you have to go? You have to go till 1 2 3 4 up to n, and then you go n minus 1, n minus 2 and till 1. This will be the answer. Understood? This was a famous pattern that was there. Like if you have heard about Shakuntala Devi and all, in her book you will find patterns like this. Okay, so this is a famous pattern. Now they gave actually this question in 2023 based on it. It says each digit of a 9-digit number is 1. It is multiplied by itself. What is the sum of the digits of the resulting number? What do you think? So it will be like 1 1 1 triple 1 triple 1 triple 1. Now this only is repeated twice. Correct? So this into triple 1 triple 1 triple 1. Now 9 times 1 is multiplied by 9 times 1. What will be the answer? What will be the number? You know this. What will be the number? Pushing it there. So the number will be this 1 2 3 4 5 6 7 8 9, then 9 8 7 6 5 4 3 2 1. Correct? Because it was 9 digit, you have to go till 9. Now one thing, how you can do this quickly. So basically this number is divisible by 9 very clearly. 1 times 1 1 1 1, if you add it becomes 9. Correct? So this is divisible by 9, and this is also divisible by 9. Now if both numbers are divisible by 9, so basically you are multiplying two multiples of 9. You are multiplying two multiples of 9, so ultimately what you get, this will also be divisible by 9. This is like if you multiply, for example, 9. If you multiply 9 and 90, what you will get? You will get 810. And this, because 9 is a multiple of 9, 90 is also a multiple of 9, then 810 is also a multiple of 9. So that means whatever is the number here, this number n is divisible by 9. If it is divisible by 9, then the sum of digits also must be divisible by 9. Why divisible by 9? Because that is the rule of divisibility with 9. So that means whatever is my answer, it is asking you sum of digits of the resulting number. Whatever my answer should be divisible by 9. Correct? Now, if you look, whatever my answer should be divisible by 9. 64 divisible by 9? No. 80 divisible by 9? No. 100 divisible by 9? No. 81 is the only option. Understood? So this you can do quickly, or you already know the entire number as well. So if nothing works, you just have to add till 9, and then from 1 to 8. Okay, we learn a formula called n into n plus 1 by 2. From that you can do the addition also very quickly. So 1 to 9 you have to sum, and then 1 to 8 you have to sum. That's it. That will give you the total sum, and then you can see what is the sum of digits. That also works. It comes out to be 81. Now, yes Dheeraj, yes Neelam. Now, when we did this question in last, like in last year, okay, before the last year when we were doing this in course. Now we were able to see this 81, but most people didn't concentrate how we are getting to this number. Okay, and that is why, that is when I told that maybe they will be asking a question that requires this knowledge also. Here just by elimination you are getting the answer, correct, trick lag gaya. That is, you can just see what is the sum of digits, it has to be a multiple of 9, but you should know this pattern. Why? Because in 2025 they gave this question again, but this time you have to see it. So now it says what? Now, if you really knew the pattern, this is an oral question. If you didn't, it becomes long. Okay, and there is another trick that you have to use. But if you know the pattern, because it was in PYQ, now it is very simple. If n square is equals to this, then how many digits does n have? What is n? If n square is this, what is n? N is what? N is 1. N is how many times 1? N is 1, 1, 1, 1, 1, 1, 1, 1, 1. Why? Because it is going till 9. So n is very clearly this. How many digits? Very clearly 9 digits. Answer becomes B directly. Okay, that's why PYQs are important. Okay, so that's it for this lecture. In the next lecture, we'll see more concepts. There are quite a few. Okay, so it will go on. That's it for this class. Yes, Dheeraj. Thank you. Yes, Mrigendra.